Okay, now to save a little bit of time on the applications, what I'm going to do, I'm actually going to set up the system. But as far as the solving of the system, it'll be done exactly like numbers 1 through 5 were done. But we'll just show you what the solutions would be, but we're not going to go through the steps of actually solving it. It says the theater sells 3 types of tickets, and more than likely that's going to be your 3 unknowns. There's your 3 types of tickets. We'll call it X, Y, and Z. So our general admission tickets, our senior citizen tickets, and our child tickets. Mark bought 9 general admission, 2 senior citizens, and 3 child tickets for $170. So he bought 9 X's. He bought 2 Y's, the senior citizen, and he bought 3 Z's, and it cost him $170. Sarah bought 5 general admission, that's 5 X's. She bought 4 senior citizens, and she bought 7 child tickets, and it cost her $173. Now, here's the key. If you have 3 variables, you need 3 equations. So it's going to have to give you another person. Kyle bought 4 general admission. He bought 1 senior citizen, and he bought 6 child tickets, and it cost him $116. Let me try that again. $116.50. Find the cost of each type. Again, you can use substitution. I don't know how that 6 jumped up there. So there's your system. Now, again, the process from here is substitution or elimination. I would use this Y to cancel out my Y's in the other 2. So I'd maybe group these 2 together and then group these 2 together to find A and B. You can find it by using substitution or elimination because it's very easy to either use Y to eliminate or to solve for Y and plug it into the other 2. Once you do that, here's going to be the ticket prices. Your general admission was $13.50, your senior citizen was $11.50, and your child's ticket was $8.50. Number 7, Jamie has collected 78 nickels, dimes, and quarters worth $12.40. If the number of quarters is doubled, the value becomes $22.15. How many does she have of each? So we'll let our nickels be X, our dimes be Y, and our quarters be Z. She has a total of 78, so that's the first part of the equation or system. I know there's a total of 78 coins. They're worth $12.40, so let's go with that. And notice what I do here. Each nickel is worth 5, each dime is worth 10, each quarter is worth 25. Whoops, 25Z. So if you're going to use 5, 10, and 25, make sure you don't use $12.40, but you use $12.40. Because we didn't use 0.05, 0.10, and 0.25, so we're not going to use the dollar amount, we're going to use the number of cents. So there's the second part. Now, if the number of quarters is doubled, now this makes it a little tricky. So the number of nickels stay the same, the number of dimes stay the same, but the number of quarters is now doubled. We're going to talk about the value now. So the nickels are still worth 5, so it's still 5x. The dimes are still worth 10, and these quarters are still worth 25, but there are double the amount now, and the total amount is worth 2215. So these 2z's, if you want to clean this up, 25 times 2z, you could actually write now as 50z. And that's going to be your new system. And once you solve it, you're going to find out that the number of nickels is 25, the number of dimes will be 14, and the number of quarters will be 39. That will be your solution. Number 8, Mason has a collection of 49-cent stamps, 20-cent stamps, and 3-cent stamps. So that'll be your X, your Y, and your Z. They're worth $23.55. So therefore, each of your 49-cent stamps is obviously worth 49 cents. Each of your 20-cent stamps is worth 20, so that'd be 20 times Y, and then 3 times Z. The total value, and again, if you don't want to use decimals, make sure you use 23.55. It says he has 56 total 49 and 20-cent stamps, and the number of 3-cent stamps is 9 more than the number of 20-cent stamps. So the 56 total 49 and 20-cent stamps. So the number of 49-cent stamps plus the number of 20-cent stamps is equal to 56. Yes, again, it says 56 49-cent stamps and 20-cent stamps. So that'd be x plus y is 56. So there's no z's there. That's going to actually make your problem a little bit easier. Next up, it says the number of 3-cent stamps, which would be z. The number of 3-cent stamps is 9 more than the number of 20-cent stamps. So it'd be y plus 9. Now, if you want to change that around, we can get that in the form that the other equations are written in. We can move the y over here, and it becomes a negative y, and you can erase it over there. So that'd be negative y plus z is equal to 9. So negative y plus z is equal to 9. Now there's your system. And you're going to do it the same way. You're going to pair them together. And probably what I do is pair these two together and pair these two together. You can very easily solve for z. And really, you're not going to have to change anything here. But when you solve for z and you pair these two together, you're going to plug, I'd use substitution, plug into z, y plus 9, solve it. You've eliminated z's and go through the exact same process. And you're going to find out your answer, x, y, and z, will equal 40, 16, and 25. Okay, number 9. It says the 3 medals earned in the Olympics are gold, silver, and bronze. In the 2014 Winter Olympics, the United States had 28 total medal winners. So we already see that X would be your gold, Y would be silver, Z would be bronze. They had 28 total medal winners. There were 2 more gold medals than silver. The number of bronze medals was 4 less than the sum of the gold and silver. How many winners of each type? So there was 28 total. So we know that the number of gold, silver, and bronze added together would be 28. There were 2 more gold than silver. So 2 more golds, the number of golds would equal the number of silvers plus 2 more. 2 more golds than silver. So the silver plus 2 would be gold. The last part says the number of bronze medals, and we know that the number of bronze medals was Z, is equal to 4 less, so that'd be something minus 4, than the sum of gold and silver. So gold and silver was X plus Y. You don't really need parentheses around it because it wouldn't really do anything. So the number of bronze would be X plus Y minus 4. Now you could leave it like this, or if you want them written in that standard form that you're used to seeing, you can just move some stuff around now. Let's leave our X in the second one, move the Y over, it becomes a negative Y. The last one, you can leave the Z, and we're going to move these X's and Y's to the left side, and that becomes a negative X and a negative Y. The Z is positive, and that would equal negative 4. So there would be your new system. And once you solve it, the number of gold, silver, and bronze medals would be 9, 7, and 12. Okay, number 10, last one. It says Enrique has a pay-per-use plan on his cell phone. It costs 10 cents per minute to talk, 20 cents to text, and 25 per picture message. Again, you see the X, Y, and Z already. His total bill last month was $30.95. The total number of text and picture messages was 87 that he sent. The cost for use of minutes was $1.60 less than the cost of the text messages. Find the number of talk, text, and picture messages he used. So first off, let's identify the X, Y, and Z. We'll say that the number of talk messages or per minutes that he used was X. The Y would be the number of picture messages or text messages, and Z would be the number of picture messages. His last bill was $30.95. So he's paying 10 cents per minute to talk, plus he's paying 20 cents per minute to text or per text, and he's paying 25 cents per picture message, and that's going to cost him $30.95. Now again, you can use 10x, 20y, and 25z if you want to use 3095. So that might clean this up a little bit as well. The total number, let's read this sentence now. The total number of text and picture messages. Okay, text was y, picture messages was z. So we know that y plus z is equal to 87. The last equation, the cost for the use of minutes was $1.60 less than the cost of the text messages. So the cost for the use of minutes, now let's go up there, that the cost for the use of minutes was 10 cents per minute. So the cost of the use per minutes, or the minutes to talk, was $1.60 less. So we're going to subtract $1.60. That's $1.60 less than the cost of the text messages. And the cost of the text messages were right here. It was 20 cents per, let's do 0.20 per Y. So the cost of the, again, let's read that again. The cost of the talking was $1.60 less than the cost of the text messages. So there's going to be your three equations. And again, if you want to clean that up, here's one way of doing it. The first equation, I'd multiply everything by 100, and that would turn it into 10x plus 20y plus 25z is equal to 3,095. Just looks so much cleaner. And you could actually go through that and divide everything by 5. I see everything's a multiple of 5 there. We also know that y plus z, that was pretty clean already, is 87. And our last equation, I'm going to move my x's over, or my y's over, and I'm going to multiply everything by 10. So that's going to be 10x. When you move the 0.20 y's over, that'd be minus 20 y's, will equal, and I'm multiplying everything by 100, so that would equal negative 160. Okay, now when you solve that, your x, your y, and your z values are 128, 72, and 15, which again was how many minutes he talked, how many text messages he sent out, and how many picture messages he sent out as well.